So our topic today is an introduction to differential calculus or differentiation. We will be doing differentiation today, and we are also going to see that how this concept is related to marginal analysis. And because it is related to marginal analysis, that is why it has wide application in economics. When we say marginal analysis, we are talking about all marginal values like marginal utility, marginal revenue, marginal product, marginal cost, etc. Right? When we say marginal, what do we mean? We mean one additional change in the value of one unit when the other unit or other variable changes by 1 unit. Okay, now let us come to what is differentiation. Now, let's say there is a small increase in the value of x, delta x, and this change in value of x, small change in value of x, changes y by delta y. So, per unit change in the value of y will be this. Now, when we say per unit change, what does that mean? When x changes by 1 unit, by how much value will y change? So this is known as the marginal value of y. Now, what do we mean by marginal value of y? That when x changes by x is changing by 1 unit, so y will change by this marginal value of y. We can write it as my. Now, this delta x, when this change in x is very small, when change in x is very small, then this delta y by delta x becomes derivative, and we do not write it as delta y by delta x, we start writing it as dy by dx. So when the change delta x becomes dx, our delta y by delta x changes to dy by dx. So this is basically slope. This is basically slope. Now, what do we mean by slope? We have already discussed the concept of slope in the previous video. Now, slope is, I told you, when we were writing y is equal to mx plus c. So this m here was the slope, or it was the gradient, also known as the gradient. And right now what we are saying is slope is, dy by dx. This is the slope. This is the slope. So here slope is nothing but the change in the value of y when x changes by a very small amount, right? Now, if you want to depict it graphically, we have already said that how do we calculate the slope of any curve or any line? Line, I've already told you, it's simply delta y by delta x. Now, when we are trying to find out the slope of a curve, what is the way? Let us say if we are never asked to calculate slope of a curve. What are we supposed to do? Slope of a curve at a particular point P. Let us say this is the point P. So we will straight away draw a tangent to the curve at the point P, and then slope of this tangent delta y by delta x. This slope of the tangent will be called slope of the curve at point P. Okay, so if you remember, when we were doing indifference curve analysis in microeconomics, what was the slope of the indifference curve? It is known as a marginal rate of substitution. On the x-axis, we used to take good x, quantity of good x consumed, and on the y-axis, we were taking quantity of good y consumed, and the slope gave us the marginal rate of substitution. What does that marginal rate of substitution? What does that mean? That if a person wants to consume one additional unit of good X, how much units of good Y he will have to uh, sacrifice or not consume given his budget constraint or given his preferences. So this is one application of the concept of slope in economics. Along with this, there is another formula for slope. M is equal to tan theta. Now, what is this tan theta? Tan is a trigonometric function. Tan is a trigonometric function, and you take this slope, this line, and the slope of this line. When you draw this line to the, keep drawing it till it touches the y-axis, x-axis, and the angle that it makes with the x-axis, theta. So calculate the tangent of that and you will get the slope. So this is also one way to find out the slope of a line. So we have got now the three formulas. Y is equal to mx plus c. Dy by dx is also the slope, and m is equal to tan theta is also the slope. So that's it for today. We will continue later.